Right, so some of you were asking that you're still having trouble with the properties, and so I want to walk you through them. Right, so here's a bunch of examples. So if we have a to the fourth times a to the sixth, this would become a to the 10th. We add the exponents here. And the reason that happens is because a to the fourth really means a times a times a times a. And a to the sixth means this, 6 times. So when you add all of these together, we have 10 a's being multiplied, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can count them. And so that becomes a to the 10th power. So anytime we're multiplying terms that have the same base, right? The base is the a, we add the exponents. So let's try another one. If we had 2 to the third times 2 to the second, we could keep the base the same and add the exponents. 3 plus 2 is 5. And then if you had a calculator, you could enter this into your calculator. 2 to the 5th power is 32. If you don't know how to enter that into your calculator, you're looking for that caret button, the same one we were using on the computer. And that should tell you 32. What about b squared, b to the 5th, b? Notice there's no dot here, but this is still multiplication. So we keep the base the same and we add the exponents. On this problem, there's an invisible exponent on the last b there. It's an invisible 1. So if you don't see an exponent, you just write it in yourself. So 5 plus 2 plus 1, add that all together, you get 8. Right? And then for people who are looking for a little bit of a challenge, we can do something like this. Notice the base is a negative number. So we're going to keep the base the same in parentheses. And then negative 2 to the 6th power is 64. If your calculator is telling you negative 64, make sure you put parentheses around the negative 2. It makes a difference. And then last one with a negative base there. Keep the base the same. Add the exponents. Negative 2 to the 5th is negative 32. So notice sometimes here we get a positive answer and sometimes we get a negative answer. It all just depends on how many negatives we're multiplying. In example 4, we're multiplying a negative number 6 times. So all those negatives will cancel each other out. Whereas in number 5, we're multiplying a negative number 5 times. So there's like an odd number that's by itself, and so that results in a negative. All right, so that's one property. The next property is if we have a power to a power. So if we have x to the 4th to the 3rd power, what this means is we take the base is x to the 4th, and we would multiply it 3 times. It would repeat 3 times. This is what this means in expanded form. And then you could take each of those x's and say, well, this is 4 x's, and this is another set of 4 x's, and this is another set of 4 x's. So count them all up. How many do you have altogether? You have 12 of them. So the shortcut here in the original problem is that if you have a power to a power, that's what this is called. If you have a power to a power, you multiply the exponents, right? So on this property, here's an example. If we have y to the 3rd to the 5th, multiply the exponents. Here's another example. Multiply the exponents. 3 times 3 is 9. If we have a number there, keep the base the same. The base is the 7. Multiply the exponents. Multiply the exponents. Okay? Now, we add to that and we say, well, we can put 2 things on the inside. Let's put 2 variables on the inside instead of just 1. The rule is still the same. You take the number on the outside and you multiply it to the exponents. So this would become a to the 9th, b to the 12th. Multiply the exponents. Now let's throw in a number here. Let's say we had 3 squared m to the 6th power. You multiply the exponent. So 6 times 2, keep the base the same. The base is the 3. 6 times 2 is 12. Now the m has an invisible exponent. There's an invisible 1 here, m to the 1st power. So we multiply 6 times 1 becomes m to the 6th, right? And then what we usually do is we simplify 3 to the 12th on our calculator. This is a very big number, right? So this would be my final answer. We simplify those numerical values. All right, what about if we had 2xy to the 5th? Each of these has an invisible exponent. You just don't see it. 2 to the 1st, x to the 1st, y to the 1st. So we multiply that outside 5 to every exponent. So 5 times 1 is 5, 5 times 1 is 5, 5 times 1 is 5. And then 2 to the 5th is 32. Okay, so this helps with the 3 properties. Hope you guys found that helpful.